I was telling you, hey, each one is a term. However, there's something important about you're identifying it when you have a sign in front of it being a negative. So this one is the one that gets everyone, I think, including yourself.
Yeah.
Oh, yeah, and don't forget, when you list them, you put a comma in between. So, of course, the answer should be A, right? You see that? Yeah, you put a comma. All of them, including the number kind, the 10. Everything that being added or subtract. Now, what about multiplication? Now, it's a little different. They normally will never ask you when it's kind of like group in the parenthesis or anything. However, there's a multiplication already involved. It's a 5x, a 3x, and a negative 2a. That's 5 times a, 3 times b, negative 2 times a. So it's already kind of embedded in there. So I don't think you should worry. But yeah, I can see they're trying to trick you with these, like front numbers and including the 10. But yeah. I just noticed this for the first time. That's why I'm emphasizing the negative. You see, you see that? Look at this one. They went with it without the negative. That would be wrong. So so that's why this is important. Anyway, in algebra, you'll know it like very soon, if not already, that when you do your algebra with the variable things, the negative in front is going to be the key, especially in solving equations. It's coming up like right away because this thing is like the left side of the equation. So they're actually having you identified and dissecting and analyzing it. So that you can handle moving on, like solving equations and things like that. Okay, what about this one? Let me see. Identified, same thing, terms. Okay, so I think you can tell that all of them. So it should be D. Let me double check there. Right, 9. Oh, where's the 8? Oh, wait, am I reading this wrong? Identified like, I'm sorry, like terms. Oh, careful. Let me read back. Identified the terms. See, they should boldface it, the terms. So terms are all of them. Like terms. Yeah, like terms. Let me see. C. Yeah, that's it. Let me double check. There's no Y, another Y, you know what I mean? Yeah. Hey, you remember how I organized it? Like I put I think the quiz prep, I had you list them in two rows, right? So it's I hope you're okay. I hope you're okay. So this one they organized with the comma and the word "and" in between. I actually don't like it, but it's necessary for multiple choice, like layout, right? You can imagine. So yeah. Anyway, you know what? I never thought of it for multiple choice now. If I were to do it by hand, I would not list it with the word "and" because this thing is awkward. It shouldn't be near algebra. Well, I take that back. There is a concept relating to the word and or in algebra, but not when you list them next to variables and things and like terms. It's awkward. But I understand why they did that. Okay, now this time for 3 coefficients. Now, what do you think? Coefficients.
Coefficients.
So if you recall,
9 and negative 8.
9 negative 8. Okay, that is correct.
Wait. And 1.
And 1, yes,
So
9. That's right. Yeah, just be aware. This is something you'll get used to also, because you when you solve. I'm going to show you right now why. Okay, I'll show you right now. But yeah, there's a hidden one or imaginary. No, so I take that back. Not imaginary one. You imagine there's a 1 there, because there is. In algebra, it's always a 1. Even this 12, it's really a negative 12. Okay. Maybe that's not a good example. Even this 5a, there is a 1 times 5a. There's a 1 times 5a. Even negative, sure, a negative 2a is a negative 1, not negative 1, a 1 times negative 2a. There's always something in front of it. So it's like you to always think it, because you need that 1 moving on. It's huge. It's like it's one of the main thing that you deal with in algebra all the time. Like anyway, yeah. So it's D. It's D. Oh yeah, I was going to show you why. Here we go. If you were to solve this equation, negative p, I know you saw p equals 5. You work your way down to this row, and you got a negative p. Your objective is to solve for a variable, a positive variable, so it has to be p. The way you solve this is that you have to imagine there is a negative 1. I know this is a 1, but this one has a negative, therefore it's a -1 equals 5. And then how do you continue solving it for p? You divide both sides by -1. You might have seen something like this before. That's why that you have to imagine there's a 1 there, or a negative, in this case, -1. That's why the answer is going to be -5 for final answer. So I'm just making this up because it's coming up very soon, but it's not just going to be this. It's just going to be something else that you need the 1 for. Yeah, this is one of the reasons why you have to imagine a 1 or a -1 in this case. Okay, I'm sorry. Let's continue. 4. What do you think? The constants. The constants.
Just 15, right?
Yeah, just 15. Just 15. Yep. B. 5. Okay, now no more identifying or vocab. The only vocabulary. We're just going to distribute. Okay. Okay. Tell me, what do you think the answer should be?
18x minus 45.
Yes. Yes, not 45.
A.
Yes, very good. A. I do like it better when you have to actually fill in a blank, because you have to think more. When there's, I think, in psychology, this is the worst case, because you get to see the answer, in front of you. While when you do something, you have to be able to do it. Now, this is psychology stuff, right? You might not know, but in education, in education, it is better for you to generate the answer than seeing the answer first. So this is like psychology thing, right? So you can generate it. That means you know it. So like writing it out. So I'd rather see a blank, but okay, it's fine. 6. All right. What do you think? If you distribute, right? Yeah, it would be a negative timing whatever's inside the parentheses.
I think it's C.
Let me see. So if you distribute this in, so watch. This is how I would do it. Like 6m. I want to see and I'll compare. I see what I get here. It'll be plus 12n and then minus 24. Yep, you got it. So it's C. Why did they all look the same? Yeah. Anyway, it is C. Yeah, with the plus being there instead of minus and all that. I see. Yeah. Very good. Very good. Okay. What about 7? I think we're going over here. Yeah. All right. Simplifying. All right. Combining like terms where you can. Where you can.
Okay. 8s plus 9.
8s
Oh,
plus 9.
8s plus 9r.
Let me see. So if I were to combine, well, anyway, my S I see first, so I'll combine it with this one here. Look how I eye this. Now you don't have to bubble this, but when it gets longer, you may consider bubbling it. Now when you bubble it, right, or slash it out. Okay, I'm gonna show you what I mean by that. You want to, if you were to bubble or slash out, you want to make sure you include the sign in front of it from left to right. I know there's a plus there. Even a minus, especially a minus. I'm sorry, especially a minus. So if you were to slash it, it will look like this. Slash the whole thing with the sign included. Now, again, you don't have to do any of this. You could just eye it because this is so short. But when it gets really long, you may have to consider a way to organize it. Now, let me see. So I would have an 8s and there's a 1 here, like a plus 1 here. Therefore, it's a 9r plus 9r. So now, but they of course combine the r first. So C, right? You said, yeah,
Yeah.
that's it. So it's commutative property of addition. If you were to switch them around to make it look the same, so it's commutative property of addition if you were to match it perfectly. Okay. Oh yeah. Well, I was saying earlier, when you can combining them. I know I didn't slash through these ones. You don't have to. I normally don't slash through the last pair if it's combinable. What do you mean by when you can? If there were another number back here, I'm making this up, like 99. Therefore, that's not combinable to anything. That's why you would only ignore it. Imagine that. I'm just making this up. Okay. Well, what do you think about this 8? Let's see. I know you're
8.
working on it. I'm glad. I can hear your pen, your writing. I'm glad. I would do the same. So yeah, y plus 9x, copy everything, and then I'll look at it. Combine like terms or similar terms. So what do you think? And yeah.
I think it's A.
Yeah, it is A. 9 and 3, that's 12x. And only, and there's nothing combined with the y term. So you just bring it down, but then the 6 minus 5. But don't forget, the minus belongs to the 5 in front of it. So that's why you would subtract. And 6 minus 5 is 1. So it's A. Very good. Good job. Yeah. Okay, this one. Now, here's the thing. They often do this with the parentheses around two things at a time. This is considered a binomial, combining two binomials. Now, this problem can be written entirely without the parentheses. Now, let me show it to you right now. Now, then you may be asking, why did they put the parentheses there? Now, for a different reason, they emphasize it so that, hey, they belong together for something else before, I don't know, this particular problem can be coming from somewhere else, like another problem, and then you simplify and you get this. Now, or they just do it randomly to see if you can actually pick out the like terms. So what I'm saying is that it does not have to have the parenthesis at all. However, if this were a minus instead of a plus, it would change everything entirely. You will need the parenthesis back here. You will need the parenthesis back here. However, the front parenthesis here can be still ignored or eliminated or overlooked. So anyway, yeah, I guess all I can say is that you can get used to both form, but they do this for a reason. A binomial combined with a binomial. So that's the way I see it. Okay, so what do you think? The answer should be
8p plus 13.
8 plus 13. Okay. Not quite. So you want to
What?
make another one?
I think it's A.
It's A. Now let's talk about it. I'm glad. Now this is something that, yeah, I get it. You're still getting used to. So when you scan, like in math, reading like this long strings of like expression combined, you're attempting to combine. When you come across like a minus something in algebra, you want to imagine it's a minus 7, a minus 6. It's like attached to it. Why? Here we go. You've seen this. I've written something like this before. Because earlier on, you're supposed to know that it's supposed to be written this way. I know there's a P, should not be P. I mean, early on, you don't deal with variable and a plus negative, but you can still think it because that is exactly the reason why the answer is a negative or a minus 13. So here it is. So let me emphasize it. You see this? So each of the expression can be written as a plus, like instead of a subtraction or addition. So each binomial can be written as an addition. So there it is. That's why the negative belongs to the 7. That's why the negative belongs to the 6. But you'll get used to this without having to without having to imagine the plus in between. Trust me, it's just going to be second nature. So anyway, yeah. So that's why it belongs to the 7. The negative belongs to the 6 also. That's why it has to be A. So I hope you're okay. Yeah, keep that in mind. Now, yeah, there is no negative in front, like to distribute, to change it into a plus. So that's why you have to carry the negative with it for the final answer or combining it to get your negative. So it's A. Okay, good. Here it is, 10. So, all right. So this is how I would have done it. I know you probably got the answer already, but here, let me go ahead and write this. Distribute. You don't have to, you ignore the parentheses, the set of parentheses for the first binomial. So here, if I distribute, it will look like this. And, a negative. What's up with the negative? Well, if you don't like distributive property, you can think it's like, hey, subtracting the whole thing. But I don't think you guys, I'm sorry, you have to split them up. I think you guys have not been, able to see as a binomial combining to this binomial. Like, I don't know.
Yeah.
Okay, anyway, you distribute the negative, but what is it? A negative 1. It's a negative 1 being distributed. A negative 1 times y, a positive y between the parentheses, it's a negative y. A negative 1 times a negative 2, it's a positive 2. So there it is. And then you can combine them. So what do you think? Final answer?
I think it's just number. I think it's just number D.
It's D. Let me see. I think that is correct. Yes, D. Yeah. So it is D. But I hope you see how I kind of like do my second step like this. I do it. Now, I don't write the whole thing in college. You would just write this portion right here, just this part right here, right above. Have a look. Y plus 2. And then we eye this together. Get it? That's all we do. So don't worry. I think you can do that now. I'm pretty sure you can do it the same way. So we don't write like the whole second row clean. We just go ahead and shortcut a little bit, fix a little bit, add, then add. But same answer. Yeah, if you're curious, that's exactly how we do it. Now, most of us, at least. All right, or I'll take that back. Many of college, like, they're majoring in math or science. They probably don't need that at all. They just you can see it. You can see the answer by looking at the problem. No kidding. Mental math, all of it through. But no worries. Yes, make sure we get the right answer here. Okay, distribute. Now this is. I'm glad they don't give you any choice to look at. The way this work is that you can still do it mentally if you wanted to, but you're supposed to be taught to write them out, looking like this. Have a look. Now, there's two way of like punctuate this. You could do a dot. To me, it's cleanest right now. Now, when do you not do the dot thing? You don't have to do the dot. You can parenthesize it, like right here. Now, the reason you don't have to do the parentheses is because you don't have a decimal number, right? You see, if you do a dot, it might look like a decimal number on its own, like 2.6, but you're dotting this to multiply. So subtract is subtract, and then 2/3 dot 18. Now, I even look at this and I don't like it myself because I'm not used to having to put the dot anywhere unless I really need to. So here's another version. You saw it already, but I'll write it. This is actually, to me, it's better. I should have actually. I know I told you, but I want you to look at both version. If you were to like write the next step, it could be either one like this. So you can pick and choose. But had it been a decimal number like 18.5, I would never use this decimal, not decimal. I would make the whole thing. I would parenthesize everything to emphasize the multiplication. So anyway, distributive property means multiply inside each one. Now, how do you continue from here? Well, you could imagine a 1 underneath each, of the terms, the 6x and the 18, and then cross cancel. 3 can go, you don't have to, you can multiply straight across and then divide it by 3. But if I had a chance and I can do it, like cross cancel, I recommend you do it. This is very important concept. Many people don't think it's a big deal, but it will be later on. I know I keep saying that, right? 3 can go to 6 2 times, itself 1 time. So therefore, I'll be left with 2 times 2x. So it's going to be 4x. Over here, same idea. If you can, cross cancel. 3 can go into 18. What is that? 6 times. And itself 1 time. And then multiply straight across. So you're left with just 12. Minus stays minus. 12. Final answer. So I'll check it here. Watch. I'll put a 1 here, put a 1 here. 3 go into 6 2 times. It becomes 2x. Then 2 times 2x is 4x. Yep. Over there. And 3 can go into 18. 6 times. 6 times 2 is 12. Yep. Minus. Is that okay? Henry, you follow it okay?
Yeah.
Yeah. So, yeah. Okay, this one. Distribute again. But make sure you carry that negative here in front of the 8. So it's negative 8 times x. This time I'll parenthesize it. Now, this one. You have 2 ways of doing this. If you have done it long enough, it will look just like this. It will be automatic plus 48. And then you know what? I take that back. It is the answer. I'm going to write it without the parenthesis because you should. This is the fastest and cleanest way. It becomes negative 8x and a positive 48. Yeah, I had the parenthesis there earlier because I was trying to mimic this second row, but I realized that, hey, this is way shorter. So you just jump to it, the answer. Now, what was I saying earlier? Some student may actually do it this way. Have a look if they're not used to it yet. But I think you know that it's awkward. It's like a plus negative 8 times negative 6. This is actually redundant. I don't think you should do that because everyone kind of go eventually. I mean, you for sure, this is the answer, even from here to here. But what I mean is that most students will go at it like this, just the answer, just like that.
Couldn't you also do 48 minus 8x?
Yes. Okay. Good point here. Yes, exactly. You can do 48 minus 8x. Now, the reason why this one is not in that order is because you know how you start with 8 and then you go at it like from left to right? That's why this looks
Yeah.
like what the answer most student would write. But here's the deal. This here is actually a standard writing. Let me explain. If the computer were to pick between this two as an answer to a question, to like an algebra problem, there's a program that basically generate answers. Like, I think you've seen it, dude. I might have shown it to you. This particular
Yeah.
program, the Alpha Wolfram Alpha, you could literally head in if you know how, right? Like side to side. Sometimes like exponent students have a hard time. They have to learn it in algebra too, I think most often. Yeah, if you know how to put in the whole equation you need to solve, I'm not kidding, like advanced equation, this thing will generate, it will solve it for you. So anyway, if I were to punch this in, I can show it to you. It might generate this, but this is a simple a simple distributive property. It's not an equation. It's just a simple, what do you call it? Simplifying, like, yeah, simplifying kind of thing, right? My guess is it will generate that, but I'll do it. Let me do it. Yeah, we have time. We have to. Let me do it. I want to see what it looks like. Watch. I'll do a -8. Now this is online. It's not an app. It is an app here, but it's also online, free. You could, like Google it and maybe bookmark it. It's Wolfram Alpha. It looks just like this, okay, with the same logo and everything. Then you can test this out if you want. So what was that again? It's x minus 6. Have a look. X minus 6. Let's see what it looks like. Okay, all right. As enter, it will know exactly what to do. It will give you a bunch of choices. Sometimes like it doesn't know exactly what is it that you want. It will give you a bunch of stuff. A graph. We don't have the graph, but it gives you the graph. But it's also going to simplify it. Here it is. See, I told you. You see that? 48 minus 8x. There it is. Now this is computerized because it's standard. Now, if you wonder why, no, wait, there's a line property. There's more stuff in there. There's more stuff in there that you may need later on in like algebra 2, for example, or engineering courses. No kidding. So now x equals 6, don't worry about this because you're not doing this yet. But let me explain why did they do that. Look, here it is. You saw it right there, 48 minus 8x. Why is it? Because in algebra, they don't like in a computer, not your teacher, not you yourself, that most students will write this as the answer. It's actually quite acceptable. It's acceptable. It's perfectly acceptable. But in computer, they don't like to see the negative being the first in the series of things. So they would flip it or use commutative property to write in the back so that it's cleaner looking. I guess it's computerized. So anyway, there it is. So I'm glad. I was guessing that, but it went with this. But this is what the teacher will accept. If the teacher were to do this problem, number 12, most teacher will write this answer. No kidding. Okay. The negative first because of the way it's organized. All right. 13, same idea. Let's do it. I know, I'm sorry. I talked
Would
too
you
much.
accept 48 minus 8x?
Yes, for sure. 100%. Yeah, for sure. 100%. Yeah, you can write either. Now, I know that you may want to be fancy with it, but it's not a big deal. It's because you need to know both form eventually because there's reason behind it. Okay. It's good. There's more to it than that. In calculus, when you actually try to do something with this or this, like an integration, I know this is fancy symbol here, integration, this is calculus on top of what you have here. It's nicer to do it with the 48 minus 8x than this one. There's something about that. So anyway, yeah, there's the different reasons for different things. So if you wonder where the calculus looks like, here it is. This is a calculus student. But let me go ahead and show you the animation that I know this is pretty interesting. I just learned it recently that I can backtrack of what I've done. Have a look. This is pretty cool. Watch. This is what I've done with this student. There's like an animation that I've done like in the past. Oh, it's like time lapse. All right. Look at that.
Wow.
Look at that. You see that? So for this particular, I guess, whiteboard is how many seconds there? No, it's not seconds. I'm sorry, it's not seconds. It's like whatever minutes. It could be half an hour, or whatever. But this is like speed up, slow down. So there, and then I got to that point. See? So anyway, yeah, this. But I erase this. Sometimes I open a new whiteboard and all that. Yeah, so it's pretty cool. I just learned that recently that I can backtrack. Now, what I can do with that, I can look back. I can see my error. I make mistakes, but not often. But I can look at it if I need to. All right, I think we're good with. Anyway, we're over here. So yeah, the distribute. Let's do it. So it's going to be negative 2 times 5x will be negative 10x, and then negative 2 times a positive. See how I'm reading it? Like literally the sign in front. Even in my head, I see that. Yeah, negative 2 times positive 5 and 7y would be negative 14y. And then negative 2 times a negative 12, that would be a positive 24. So there it is. Now again, if you were to reorganize this, you can do it so many different ways. That's why it's not necessary. You can do like 24 minus 10x minus 14y, or you can do 24 minus 14y minus, I'm sorry, 10x, okay, 10x. Yeah, but that's why it's not necessary. Then now, which of these two would the computer prefer? It will be this one. The reason is because it's alphabetized, put everything in alphabetical order. Yeah, if you wonder, okay. I don't know that 100%, but I think it will. If I were to punch this in, it's probably going to do it like that. But it's not necessary for algebra, okay, at this level. Don't worry. Yeah, don't think too much about it. Yeah. I hope that's okay. Yeah, that should be the answer. I'll double check it right now. Yeah, looks good. Yeah, I would keep this. Okay, you can write the other ones if you want. But yeah, it looks good to me. Right, this 14 combined like terms. This one and this one. Look, that's how I bubble it too. I at least eye it, and then I get my. It's a 9a minus a 1a, or yeah, minus 1a. There's a 1 here again.
So
All right.
A plus 10b.
8a plus 10b. Yes, very good. 8a plus 10b. All right. And this one, I see this and I see this from left to right scanning. So, okay, what do you think?
Negative 7x
7, right?
plus
Yeah,
10y.
that's it. Negative 7x plus 10y. Yeah, obviously you can write 10y minus 7x. Now, since I don't know about this one, I mean, we'll come back to it if we have time. Since the computers would put everything in alphabetical order, but then what about the negative in front now, huh? Are they gonna do a 10y minus 7x? See, so it's not a big deal as long as you know that it's a commutative property that can have you write this two different ways. So that's something that you can do, So that's why you can do it. But I would I would leave it like that, dude. Here I would take the alphabetical order over the negative sign being the first in the series. So yeah, I definitely. I have a feeling the computer or that program would do it too, but we'll see. Anyway, let's distribute. I'll distribute it downward here. I mean, arc it on the bottom here. So 3 times a 1x is 3x. 3 times a negative 4 is a negative 12. And then over here, a negative 7. Okay, think negative 7. Now you can think a plus in between right here if you want, but you don't need to. So a negative 7, continue on. Negative 7 minus positive 2x is a negative 14x. Negative 7 times a positive 3 is a negative 21. So okay, this is not yet done because there are like terms that you can combine. This and this. Okay, what do you think from here?
11x minus 33.
Yes. Minus what? You said 33.
Oh, 33.
Yeah, that part is
Oh, yeah.
correct. But what do you think about the first part you said? You want to think about it?
Oh, negative 11.
Yes, negative 11. I know you know it. I hope you're okay, right? Yeah, I know you know it. Yeah, because I know casual talk is like, hey, the 14 is, it's not true, but the casual talk is like, the 14 has if 14 is bigger, it has a sign negative. Therefore, you have to keep the negative. You're going to have to subtract, right? But you keep the sign of the one that's has a bigger number. But it's not a bigger number in terms of a negative integer. Like negative 14 is smaller than 3. If you talk about the order, right, on the number line, it's closer, it's further away from 0 than 3. But that's absolute value concept. But anyway, you know it. Yeah, so make sure you're okay with 16. I'll put a star there. Yeah, so it's really 3x minus 14x. 3x minus 14x is negative 11x. Or you can think 3 plus negative 14, 3x plus negative 14x if you want. If that's going to help you keep the sign negative, you can. Sometimes this helps, okay? Negative 3x plus negative 14x. Like you print sizes if you want. All right. Okay, we're good there. Next one. This one, distribute. Negative 3, distribute n. Negative 3 times positive 2n is negative 6n. Negative 3 times positive 7m is negative 21m. Then I copy what I have at the back as is to be patient here. And then continue. All right, what do you think? I'll let you do this next step.
Negative 6n minus 22m.
Yes, there it is. You got it. Very good. All right. I think this one is pretty fancy with the m's in the back. When I touch it, it would undo it sometimes. Yeah, this is it's pretty bad. Okay, what about this one? Here we go again. Now check this out. I would eye this without the parentheses at all of them without the parentheses. Yeah, only condition is when this is negative, then there's a whole new thing, like over here, number 19. So this one, I would just eye it, combine like term. Okay, I'll let you tell me, what do you think the answer is?
8p minus 4.
8p minus 4? What do you think? Want to double check that? It is not a minus 4. Yeah.
4p minus.
Oh, yeah.
4,
it is 8p. I'm sorry. It is 8p.
Oh.
It is 8p. Now, the reason why is because we're adding the p's and the constant. We're adding the p terms and the constant. Okay, what about if I were to rewrite it without the parenthesis? I'll even put it right up here.
Oh, 8p minus 2.
Yes. Is that okay? Yeah, it is minus 2.
Yeah.
Okay, let me see. I'll write it. Yeah, so sometimes it's cleaner looking at without the parenthesis. Yes. So, yeah, I hope you're okay. What I see is negative 3 and a positive 1. And like I were to combine, if I were to like, here, if I were to see in my head, this is what I see. And then I know it has to be a negative 2. But when you write it as a whole, it's really a subtract 2. You have to write subtract 2. But yeah, I hope you're okay with that, right? Okay. All right, this one, here we go. Next step, I would take out the parentheses. I don't know why I tilt that minus sign. That's funny. Now, this is a must. So you have to distribute. It's a negative 1 being distributed in. So a negative 1 times a positive 3x is a negative 3x. A negative 1 times a positive 2 is a negative 2 or a minus 2. In this case, like when you write, as an algebraic expression, just do a minus 2. All right. What do you think? Continue? I'll let you combine them.
6.
Oh, okay. So tell me the whole thing together. You can tell me the answer. Yeah. You tell me the final answer.
Negative 6x.
Yes.
Plus 6.
Plus 6. Yeah, you got it. I know you were a little hesitant about this right here. Yeah, you got two negative x's, negative 3x and negative 3x. If you were to add their like term, the negative belong in front of them. Therefore, yep, it's negative 6x, like a negative 3x plus a negative 3x. If you were to need to have to see the plus in between them, then, hey, if you're not sure, you can also think negative 3 plus a negative 3, but then you add on the x. Negative 3 plus a negative 3, the two negative 3, like go down negative 3 and go down negative 3 again. It ends at negative 6. So that's why. But don't forget, it's coming, each one comes with an x. So anyway, this is the answer for sure. Let me double check. Yeah. All right, next one. Okay, now this is another concept. In addition to what you've done, like the ones you up here, you're basically combining similar terms or like terms. This time, it's about factoring. So now there are different ways you can teach this. Like there's a very methodical way with the tree method, prime factorization. That's actually very good, but it's time consuming. So I recommend you try it this way. Your teacher will accept it. Don't worry. This is actually probably what your teacher's teaching it. So it goes something like this. You're supposed to pull out the number that is the biggest number that can divide into 9 and 27. If you can come up with it. If you don't worry. You can continue on. I'll show you in a moment. If sometimes you can't get it. Now, the thing that you're trying to come up with is called the greatest common factor, the GCF. That's the teacher has to use that term. As a teacher, you better use it. So, but of course, it's the biggest number. The GCF is really the biggest number that can divide into 9 and 27 at the same time, including the number itself, like one of the number itself, if you need to use it. So, okay, what do you think?
Yeah.
What is the GCF?
9 times
9.
parentheses.
Okay, good. So it'd be 9 on the outside, a parenthesis, and what's inside the
N
parenthesis?
plus 3.
N plus
N
3.
plus 3.
Yeah, you got this. Yeah, I know you went over this already, so I'm glad. Now there'll be occasion where you won't be able to get the GCF, like you'll be getting the CF, the common factor, which is not the greatest. It will happen. You may think it won't happen. It will, because you have so many that's coming up, especially like like a trinomial. You may have even longer. You sometimes that happens. It happens to me. It happens to me. So all right, what about this one? What do you think?
4.
4, and what's inside?
2x minus 9.
Okay, check this out. Let me double check. Guess what? That is correct. I was I was thinking this may be something else, that you may have to pull out the 8 at the GCF, but no, 8 cannot go into 36, right? Let me double check, right?
Yeah.
Yeah, it can't go in 36. Anyway, yeah, we'll come back because I want it to happen. I want like you to pull out a non-GCF, a CF. But we'll see. All right, what about this
Can
one?
you can
Do you
you
want to see?
factor decimals?
Technically, you can, but not for the reason you're doing it here. The decimal you can factor out for application like word problems and things like later on when you need to. Not very common, but yes, you can factor out a decimal. You can factor anything you want technically, but don't forget if you were to factor out decimal for a problem like these, it will not be the GCF. That's why you don't want to do it here, because the objective here is to get the GCF. But if you were to pull out the decimal, none of these has a decimal in it. Oh, if you were wondering, we can make one. I'll do it right now. You can make one right now. Have a look. But for a GCF, right? I can do it. I can do it.
Yeah.
Watch. Watch. I'll do a 5 x minus 0.75. Ah, here we go. What? Let's say this is the problem, and you want to pull out the GCF. What do you think the GCF is? All right, this is a good one. Let me double check. I can't let you see it on the screen. I mean, double check. So, yeah, give it a shot. What do you think? How would you factor it? Yes, you can. So to answer your question, yes, you can. Like this, if they gave you a problem with the decimal, yeah, you better pull out the GCF, likely with the decimal being part of it. So let me see. What do you think? A good question, dude. Very good question. But yeah, you can also see it in like word problems applications. So yeah, but GCF, let's see if we can do it.
5 times x minus,
You mean like outside here?
yeah. Oh,
Five,
x inside.
X inside, and you want 5 here?
Yeah. And
Okay,
then minus um
minus, yes.
minus,
Okay, so you probably want to use a calculator, right? 0.75 divided by 5, it'll be point
yeah.
1, yeah, 0.15. Now, here's the thing. Is it Is it 5, the GCF, or is it 0.25? Because 0.25 can also go into both of them. Yeah, think about it, right? 0.25 can also go into 5, or any number really, with, any number that is not a decimal number. So this is one form. What about this then? Let me go and write this one. 0.25 can go into 5. How many times?
3.
20 times. Let me double check. Is that right? Yeah, 20 times. It would be 20x here. Yeah, if you do, wait, what am I doing? Let me double check. I did it. Yeah, it is correct. And then minus 3. Look at that. So watch. If you multiply, you can use a calculator to check it if you want. Okay, if you have it, 0.25 times 20. That's 5. That's why this is true. You see that? So you got two answers here, whether this into this or that, this into that into this right here. Here's the original. Okay. So you may be asked, which of these is the GCF? I have to think about that one. Okay, so I'm not perfect. Yeah, so I have to think about that. I'll admit, but it can be done. Like you were asking, right? So you were wondering, what about the decimal? You can have the decimal inside the parenthesis, or you can pull it out, outside. But if you were to pull it out, would this be considered GCF? I have to check on that. I'm sorry. Yeah, I'm not sure in terms of decimal, and in terms of but of course, you may thinking, hey, I'll take the 5 because it's, like the greatest, the word greatest, right? But it's really, don't forget, there's also common factor as part of it. It's not just the greatest number, it's the greatest common factor. So I'll check on this. That's a good question, by the way. Look, you know what? I'm gonna use this rules round right now. And we have time. I'm gonna use rules round to actually, I'll tell you the factor 5x minus 0.75. Let me see. Normally you don't have to, but you can do it. You could command it. So like this factor 5x minus 0.75. Good question, dude. Check it out. Let's see. Have a look. So here it is. So they pull out a 0.25. Yeah. So that means the 0.25 should be the GCF. Yeah. If you're curious about it, yes, you can. Okay. So I was like, wasn't sure whether a 5 is a factor, so it's not a GCF, but it is a factor that you can pull out. So yeah, okay, that was a good stuff for me. Yeah, I'm glad you brought this up. Okay, let's go back. Okay, anyway, what about this one? What is the common factor for 9, 12, and 30? The biggest, the greatest common factor. Let me see. What do you think?
For 9, 12, and 30.
Yeah. Don't forget, you got to do all of it. Yeah. So now you're doing factor. I know you may be eyeing like maybe the first two, but you have to eye all terms, all the 3 terms.
3
3.
parentheses.
Yeah. 3. 3 parentheses. 3n, right? Plus
3n. 4m
4m
minus 10.
minus 10. Yep. This should be the answer. And I'm pretty sure it is. Yep. Okay. What about this one? 23. What is the biggest number that can divide it to 32 and 48 at the same time? The GCF.
16.
16. Wow. Did you know that? Like, that's pretty good. So 48 divided by 16. So let's check it. That's pretty good, dude. 48 divided by 16. 3 times. Wow. Very good. 16 is the greatest common factor. I was hoping that you would get something else other than 16 so we can actually kind of learn it. What happens after? Actually, I'm going to do it. I'm going to do it. But anyway, 16, what do you think inside the parentheses?
2 plus 3.
Yep. You mean 2x plus 3, right? Yeah.
Yeah.
Very good. All right. This one. Okay, what about this one? Okay, write and simplify the algebraic expression for the perimeter. Remember perimeter? It's like all the sides. Anyway, the definition of it is like the distance around a figure. It doesn't matter what the figure is. It could be even curvy picture or straight even, or partly curvy. No kidding. But you learn how to deal with that. Like let's say a quarter of a circle. You know, there's a way to get the distance around that curve, but not yet. Okay. But anyway, yeah. So what do you think we should do?
Just
Perimeter.
add all them up.
Yes. You want to give it like in one shot? Let's do it. If you're not sure, you can write them all out. You know, you may have to. Sorry, they do. They ask you that. Say write. Yeah, some student will probably don't do this. I'll bet your classmates, some of your classmates will not do it. But you have to write it out. Sorry, dude. Okay, which one do you want to start first? Do you want to start with this one? I think maybe, right?
Yeah.
Let's do it. 3x. Go all the way around. Next one here. Plus
3x
5x
plus
minus 2.
5x minus 2.
Now, here's the thing. I would parenthesize that because it came as a binomial, but you don't have to. If you don't write it, it means you're going to the next step, and your teacher will accept it 100%. And here's another binomial. So this is where, like, you wonder, hey, where is it coming from? Here it is. Why are you parenthesizing it? Well, it came from a label that originally a binomial, you know, on the sides. So that's why you're parenthesizing it. But you don't have to. You don't have to at all, okay? It might be easier if you were to go for the, you know, the answer like real fast. Okay, now let's do it. Let's combine them. You want to try it like in one shot? Here we go. 3x, 5x, 4x, x, and 6x. Okay, let's do it in one shot here. 8. Use a finger if you need to. 10, 11, 12, 13. What do you think?
15.
All together? Want to try it again? Double check. Double check. 8. Okay, so I have a different answer for the x term.
90.
The 90, are you sure? It shouldn't be that big. If you add 3x, 5x, 4x, x, and 6x. So I'm doing the x first. Then we'll do the constant later. Don't forget we're adding, okay? What do you think?
85.
I think that's too big. Okay, watch. 3x plus 5x, that's 8x. 8x plus 4x, that's 12x. 12x plus 1x, that's 13x. You see what I'm, yeah.
I thought you were
Yeah.
trying to you had to multiply it because they're right
Okay,
next to each other.
okay, I see. Not multiplication, but the multiplication one will be involving area. So that's, I'm surprised they didn't give you that. Yeah. Oh yeah, I know why. Because if you multiply, right, the x and the x, you get x squared. And beyond, if you continue multiplying, you get x to the third, x to the fourth. So I believe the concept is not there yet. Your teacher is not doing that yet. You can imagine, right? Yeah. If you multiply x and x
Yeah.
and x, many times it depends how many x you have. It will raise to that many power. Now, but if one of the x's happen to be like a square, you have to add on to that one, by the way. You know, yeah, so it's different. So anyway, what do you think? It should be
44
19x? Wait, for
for,
x's? Wait, let's go
for
again.
x's.
For all the x's, right? Let me see. 3x plus 5x, that's 8x. I'm going around this
8.
way, okay? Clockwise. 8x, 9, 10, 11, 12, 12x right here.
Yeah.
13x. Don't forget there's a 1x, 13x. 13x plus 6x, that's 19x. I hope you're okay. I hope you're okay with that. Now, if you have trouble, I would recommend you do 2 at a time and then kind of write it down, like something like this. I'll watch 2 at a time. I'll do that and I'll scratch it. It'll be 8x. And maybe this and this is 5x. See how I'm doing it? Like I'll scratch that. And then the last one is 6x. And then just kind of like go at it. Now, there's different ways. You can even do 3 at a time. So anyway, 8x plus 5x, that's 13x plus 6x, that's 19x. I hope you're okay with that. There's a different way to, you can even add it the other way around, or you can pick it across each other if you want, but you have to cross them out. Anyway, hey, you have the number, the constant to combine. You're not done yet, right? So we got to combine the constant. Now, careful with the constant. There's a -2, a 0. You don't need the 0. You don't have to even look at it. A -2, a -2, a +3, and a positive 1. Okay, what do you think? You want to combine them in one shot, or how do you want to do it?
Yeah. Do it in one shot.
Okay, so let's go around this way again, I guess. Actually, I wouldn't. I would combine the -2 and -2 to be a -4, and then I would, combine it with this 2. Now, the reason why is because when you do enough, you'll be doing like a very good. You pick and choose. You pick and choose like what is easiest to combine. Like -2 and -2 will be the easiest. It'll be a -4, and then a 3 and a 1. That's a +4. Imagine that, right? A +4 and a -4. What do you think happens there if you were to combine them?
They just go out.
That's it. So it's like a +0. That means you don't have to write that. The final answer is just 19x. Pretty sure. I know it's fancy, dude. Now, that's it. I'm pretty sure it's right. However, the number 25 continues. Yeah, it is 25. It's actually you need to continue using 24. So, okay. Anyway, are you okay? How I got that? You can double check it, but I'm pretty sure it's right.
Yeah.
You can go around it if you want. One. Yep, it's gone. They all cancel. The only thing you have left is that 19x. Then number 25 says, now what is the actual parameter, right? With the number x being 5 this time. Right now, yeah.
Wouldn't it be unit squared or
Not
no?
yet. Not yet. The unit square, something with the square, that has to do with the area, the concept of area. So that's something I can share with you, but it's coming up. There's no way around it. And you'll be doing that x squared thing. Like, I'm sorry, you'll be doing here. Let me start with the area right now. So you have x and x. Let's say this is 3x. The area, like the space inside, is going to be 2x times 3x. I'll parenthesize it. So it'll be 6x squared. So the concept of like the square will be coming up. I'm pretty sure like next time. Next time. So right now it's still perimeter. So what you do is that you will take the 19x that you've got. You could even copy with the p if you want. P equals 19x that you got from 24, and then continue with it. P equals 19. When it's 19x, it means the same thing as 19 times x. Therefore, it's going to be 19 times 5 because they want you to use x being 5. X equals 5. So here it is. And then you multiply it, and whatever that is, it's going to be your answer. And let me see, what is that? 50 plus
85?
49. Yes, 85. 40, 85. Wait, is it 85? You mean 95, right?
Yeah,
I'll punch in the calculator. Yeah, 95. So 19 times 5. Oops.
That's 95.
Yeah, I think 95. Yeah, 95. Yeah, that's it. Now, there's this rule. If this were last year, I think you're supposed to actually write if you don't have like centimeters, feet, whatever, you're supposed to write the word units. I don't know, something like
Yeah.
that. I don't think you need to because you're doing algebra now, so you don't really need to, but you can still do it if you want. But if you have a centimeter, feet, you have to write that. Your teacher will mark you. At least partial credit. You only get partial credit for the number, but you get the whole credit for the unit if you have it. Now, I believe you don't need to write the word units here, but it's something that you like carry on. Like, hey, you're supposed to remember. Okay, now, quickly, just quickly, okay. Now, pretend number 23. You didn't actually get 16. Do you know why? Because I'll bet your classmate. I'm glad you got it. Some of your classmates will not get it. Will not get the 16 being the greatest common factor. Watch. Let's pretend. Let's pretend that you only thought of 8. Now, don't forget, this is the answer, but this is an example I'm about to show you. What happens if you don't get the GCF? Let's go with 8. Let's pretend you think 8 is the GCF because 8 can go into both of them, right? Have a look. So let's do it. So 8 can go into 32 4 times, so it'd be 4x here. You agree? And
Yeah.
8 can go into 48 6 times, like that. Okay? So I hope you're okay so far. Now, this is it's factored. This is factored into this. However, this is not the answer to the instruction or to this here. It says completely. That means it's not completely done. But you factored it, but it's not fully factored. What does that mean? Have a look. Now, this is something your teacher have not taught you. I'm 100% sure, but your teacher should have, because this is what happened. Unless I'm wrong. Now, tell me if this looks familiar to you. If you look inside the parenthesis right now and you ignore the 8, could you tell that 2 can actually be factored out? Right?
Yeah.
Pretend you don't see it, like a brand new problem, like a 4x plus 6. You can tell 2 is the greatest common factor in there. What that means is that you have to continue, but the 8 has to stay, waiting in front. And what happens then? Have a look. Now, this is something is odd looking. I'm gonna go. You can do another parenthesis if you want. I'm gonna bracket it because this is actually a math punctuation, proper math punctuation. So I'm gonna factor inside here and treat it as like a brand new problem inside the bracket. So here it is. I'm gonna factor out the 2. So 2 can go into 4 2 times, but it's 2x. 2 can go into 6 3 times. So there it is. So the answer inside the parenthesis is this right here, and I know you agree. But what happens now? Well, if you do this will happen in later math all the time. Not a lot, but it happens. I'm sorry, I said it sounds like all the time. It does happen. You'll continue. You have to multiply the 2 and 8, and then it will be your final answer. If this ever happens and you don't get you don't get like the GCF right off the bat, you have to carry on by factoring it further. Now with this bracket thing, you may not have to, okay? Just go ahead and ignore it if you want, but you still have to multiply the 8 and the 2. So imagine you don't, because this is something that you have to learn how to punctuate and things later on. So all you just ignore it and put a dot in front or be between the 8 and the 2 like that. And then your final answer will be 16, 8 times 2. And keep the what you have left in the parentheses as is. And there it is, same answer as you had before, as you noticed. Yeah, so it's going to happen for maybe a test problem. Maybe the numbers are big, like the coefficient and the constant are really, really big, and you don't recognize it. You may not be able to pull out the GCF. Therefore, continue if you see it. If you know that you can continue, in between the parentheses. There it is. This is just a good example. All right. I guess we're okay for now. Yeah.
Yeah.
Good job. No, I'm. Gosh, Henry. Yeah, I noticed that the sign being negative is something that you have to pay attention to, right? I hope you're okay. Do
Yeah.
pay attention to when you scan from left to right. The negative in front of it belongs to it. Like this 21, I see 8y plus negative 36. 22, 9n, I see 9n plus 12n plus negative 30. So anytime you scan like from left to right, double check the sign.